Hello everyone, my name is Thao Minh from Deakin University, Australia. It's my pleasure to present our paper titled Guiding Visual Question Answering with Attention Priors. As we all know that most of the advances in VQA are based on attention mechanisms. However, in a typical VQA system, attention scores are computed on the fly without explicit attention supervision. Analysis of VQA attention models shows that inaccurate attention often links to the bad performance of the VQA models. On the other hand, annotating human attention is not straightforward and it is inherently costly and not scalable. In this work, we aim to pre-compute attention priors without using any additional human annotations, and then use this newly obtained information to provide guidance to refine the computation of attention weights inside the VQA models. Having that in mind, we propose a novel grounding-based attention prior mechanism, or GAP for short, that plays the roles of a plug-and-play module to existing attention model to improve their visual attention, ultimately improving their performance. In order to obtain the linguistic-visual alignment, we first use a constituent patch tree to break a complex question into multiple noun phrases that can be aligned to specific visual regions in the corresponding image. And we refer to these phrases as referring expressions. We then route these referring expressions to their corresponding image regions in the image using a contrastive learning frameworks. And at the end of the process, we have the word reason alignment scores for each of the pair of the word visual reason in the given question and image pairs in VQA dataset as attention priors. Once we have the linguistic visual alignments, we use them to guide the attention weights computation inside the VQA attention models. As you can see in the figures, the VQA attention weights now attributed by two sources from the attention prior A stars and from its own on-the-fly attention computation A. In this work, we combine the two sources of attention scores using either the additive forms or the multiplicative form as shown in these formulas. We have observed that the additive forms is more helpful with marginalized attention scores, while the multiplicative forms is more helpful when dealing with the full metric form of the linguistic visual attentions. As for the empirical results, our proposed method has outperformed all the existing methods in the literature, and it has also improved on top of different models across multiple datasets in visual question answering. Another success of GAP is that it's greatly beneficial to reduce the reliance of the VQA models on the amounts of answer label available. And last but not least, here's an example of the visualization of the internal operation of GAP, where it has successfully aligned the words in the question and the correct reason in the image. And these linguistic visual alignments help shape the VQA model attention towards more appropriate reason to arrive at the correct answer. And that's everything for my talk today. Thank you for listening.